Hello and welcome back to another lecture from organic chemistry. Last lecture, we practiced the fragmentation of alcohol, and I mentioned that if the molecule happen to have a heteroatom, that the heteroatom is carrying a lone pair, there is high chance the molecule can go through alpha cleavage. And because the heteroatom, it can share a lone pair with carbon and to stabilize it. In case of amine, we can have the same story, and as you see, nitrogen managed to share lone pair with carbon, and in that case, the carbon got stabilized. And because it's stable enough, it will be detected inside the mass machine. And in case of carbonyl, also we can have it, but there is a second mechanism that it can happen only and only whenever there is a gamma carbon that is carrying a hydrogen atom on it. So we need to have a gamma carbon with hydrogen atom on it, and not only just having a gamma carbon. Okay, let's practice some example about each one, and in order to understand the detail of these two mechanisms. Okay, the first one is going to be an amine. And as you see, we have a nitrogen, and the nitrogen is not octet. So in order to make it octet, we're going to add a lone pair to it. The first step, we will bombard that one with electron, and in order to get a radical cation. So if I take one electron from the system, this is going to be a structure of the compound. I will have only one electron, and then I have a carbon that attached to tertiary group. And the mass, molar mass for the starting compound is 141. And now I remove the one electron from the system. It's not going to change anything. So this, the only thing is going to happen. We will have a radical cation, and the M over Z. I'm going to call this one. I'm going to call it radical cation. The M over Z for it is 141 again. Okay, because we only removed one electron from the system. Now what's going to happen? Okay, now we can look for the beta carbons. We have one beta carbon here, and that's going to also be beta carbon. These two are identical, and I'm going to call that one beta 2. Now, and if you look to the mass of the final product, it says 126. So we started with 141, and the mass went down to 126. So clearly, we lost something from the system. And if I subtract 100, okay, if I subtract 126 from 141, that's going to be 15, which is equal to CH3. Okay, so the thing that's going to happen, I can have alpha cleavage. In the alpha cleavage, I can have it here or there. Those two are identical. Okay, one of them is going to happen. But if I, if I bring the molecule from here, because this part is still attached to nitrogen, mass is not going to go down. Okay, yes, it's another mechanism to break the molecule, but the mass is not going to change. And because of the mass here, in this case, mass went down, and I'm going to say the beta 2 went through cleavage, and this one happened. So I got nitrogen attached to carbon. Carbon lost one of this methyl group, so that methyl group is gone. Now I'm going to have only two methyl group here. And what else? Okay, we have the ring as it is. Okay, now we got CH3 as a radical. Okay, now this CH3 left the system as a radical, so left one radical for us. And remember, we have also radical in nitrogen. So these two now very soon they're going to get paired, and they will form a double bond for us. Okay. And the charge is a plus. Okay, so now I'm going to share this lone pair with carbon, and that's going to give me a double bond. Okay, now let's check the formal charge of nitrogen. Nitrogen, I will draw a circle around it in order to find the formal charge for it. Nitrogen is a group 5, but I see only 4 electrons inside the circle, so it will be +1. Okay, so that's the reason I said the total charge is a +1. Now let's write the M over Z for it. M over Z for this species is 126. And what's the formula for it? The formula is going to be C8H16 and 1 nitrogen. Okay. And so the final product, it will be this species. Technically, it is in the nitrogen that form even bond with carbon or double bond. Okay. we practice one example about an amine. I want to switch to carbonyl, and in this case, I have a carbonyl, right, that does not have, like I have a molecule that is carrying carbonyl group, but it doesn't have gamma. Okay, gamma carbon. Let's label them. Okay, this is going to be alpha, and that one it will be beta. I want it to be here to be sensitive to where I put the alpha. Okay, and the neighbor carbon, neighbor to the carbonyl, we call it alpha, and next one it will be the beta. All the betas are identical. Okay, and I'm going to call them 1, 1, 1. I do have another alpha, and this is going to be here. I'm going to call it alpha 2. So I have alpha 1 and alpha 2. Okay, the first step, okay, we have radical cation. And remember, oxygen is carrying 2 lone pairs. So the first thing that is going to happen to oxygen, it will lose one of the electrons. So we will get this species. We'll get carbon that's attached to 3 methyl groups. And then we have carbonyl. Okay, now I'm going to leave only one of the electrons. Okay, next, we have CH3. And I'm going to call this one M plus dot M over Z for it is going to be 100. Okay, next step is going to go through alpha cleavage. Okay, the question is, which alpha do you want to break? Okay, we have 2 of them. Okay, so we can break this one, we call it alpha 1, and that one we said is alpha 2. Let's go through the alpha 1 first. Okay, if I break the molecule through alpha 1, okay, so that means this bond now it's broken. We will take this electron, we will give it to carbon, and the next electron we give it to this carbon. So we will get 2 species. We will get CH3, CH3, CH3. That's a radical. Okay, and radical we're not going to actually detect it. And the second one, okay, the second species that we will get, we will have CH3 attached to carbon, and this one attached to oxygen. Oxygen, it has lone pair and 1 radical or 1 single electron. Also, carbon is carrying it in a radical, and this one is going to have a positive charge. Okay, so I write a plus charge there, or just simply half a bracket and write plus. Now this one, it can go through resonance, and it will give you this species. Now I'm going to form a triple bond with oxygen. So oxygen is going to have only 1 lone pair, and now what's the formal charge for oxygen? It will be plus 1. Okay, and the M over Z for this species, it will be 43. Okay, so if we do the cleavage through the alpha carbon, the alpha 1 carbon, we get 1 signal that it has M over Z equal to 43. Now, what will happen if we break the alpha 2? Okay, if we break the bond, the sigma bond between carbonyl group and alpha 2. In that case, we will get another signal. Okay, let's check what's the M over Z for that species. So the bond that I'm going to break, it will be this. The previous one, I broke that bond. Now I'm going to break this one. Okay, again, 1 electron will be given to carbon, and this one it will be given to the carbonyl group. So I will get CH3 radical, and the mass or the molar mass for it is 15. And the next species that I get, it will be tertiary butyl group attached to carbonyl. Okay, forgive me. Again, carbonyl, we have 2 radicals there. Okay, this one, it can do resonance, and it will give us this cation. And the M over Z for this species is 85. So I will see a signal for this molecule, this technically cation, that I can label it as M minus 15. Okay, why minus 15? Because I lost the radical. And so whatever M was, we lost 15 of it, and that's going to show up in 85. So we will get 2 signals, one 43 M over Z 43, and the second one, it will be 85. Okay, and now I do have 2 more examples to practice, but I'm going to keep these 2 examples for next lecture video, and thank you very much.